friends, welcome to BSS Studies. I am Bala. Yesterday we have completed acceleration and types of acceleration. In that, what is acceleration? Acceleration means rate of change of velocity per unit time. Okay. So today topic is kinematic equations. Kinematic equations. So here, what is kinematic equations and what is the properties of kinematic equations? So here, I am taking a car moving from rest within 1 hour and going with the speed of 80 km per hour. In that, initial velocity is equals to 0 because it starts from rest, and within 1 hour it goes with the final speed of 80 km per hour. When it starts from rest, initial velocity is 0 and time is 1 hour and final velocity is 80 km per hour. Here they asked to find what is acceleration. Here acceleration is equals to V bar minus U bar by T. Okay. So here V bar means 80 km per hour. 80 km per hour minus 0 by 1 hour. Okay. So here 80 minus 0 means 80. 80. Here 1 hour means 80 by 1 80. So here 80 km per hour square is the acceleration. When the body comes to rest, what is the acceleration? Negative acceleration. Here body starts from rest. So here positive acceleration. When the body comes to rest, acceleration is negative. Okay? This is a very important point. When they ask a body comes to rest, we did not do sum. We directly take it negative acceleration. Okay? Because it comes to rest means final velocity is 0 and initial velocity is some k constant. Okay? So here we already know A bar is equals to V bar minus U bar by T. Here V bar means final velocity, U bar means initial velocity, T means time, A bar means acceleration. Okay. Here they asked to find what is final velocity. What is final velocity? And they gave acceleration as 80 km per hour square. Okay. So here we have to transfer time to this side. So 80, it becomes A into T, 80 is equals to V bar minus U bar. Okay. Then 80 is equals to V bar minus U bar and 80 plus U bar, because in this side U bar is negative and transferred to this side it becomes positive. So 80 plus U bar is equals to V bar. Here when they give initial velocity, time and acceleration, they ask you to find final velocity. Then the formula is V bar is equals to U bar plus AT. Okay. So in this, here what is kinematic equations? We apply these kinematic equations to get how much acceleration, how much final velocity, how much initial velocity, how much distance, like that. Okay. And here when we apply kinematic equations, we have two conditions. We have two conditions. When we apply kinematic equations, we have two conditions. In that, first condition is body should travel in a straight line. Here first condition is body should travel in a straight line. In straight line we can calculate acceleration, final velocity, initial velocity, time. Okay. So second point is body should have uniform acceleration. Uniform acceleration. Because of uniform acceleration, in some equations of motion, in these kinematic equations, when they did not mention uniform acceleration, we should not apply kinematic equations. The body should go in uniform acceleration, then we can apply kinematic equations. When they did not mention uniform acceleration, we should not apply kinematic equations. Okay, this is very important point. We should have uniform acceleration. Okay, these are two conditions to apply in some cases kinematic equations. Okay. So first equation. So here what is first equation? We already know A bar is acceleration is equals to final velocity minus initial velocity by time. We already discussed about final velocity is equals to initial velocity plus acceleration into time. So this is the first equation. Okay. When they give acceleration, initial velocity and time, we can calculate final velocity when they mention uniform acceleration. When they mention uniform acceleration, initial velocity they given and time they given, we can calculate velocity. This is the first equation. Okay. And the second equation. So here, what is second equation? V square minus U square is equals to 2AS. V square minus U square is equals to 2AS. Okay? When they mention uniform acceleration, uniform acceleration, uniform acceleration, and when they give distance, particular distance and initial velocity, we can calculate any of them from this formula. When they give distance, acceleration, when they give distance and acceleration, we can calculate final velocity, initial velocity. When they give these two and acceleration, we can find distance also. Okay? We should not do any expanding. How formula get expanded, how it's derived. It's a lengthy process. We have to learn what is first equation, second equation, third equation and fourth equation. Equations are very important than derivation. Okay? So what is second equation? V square minus U square is equals to 2AS. Okay? Third equation. Here third equation. So here third equation is S is equals to ut plus half at square. Here they give initial velocity, time, acceleration and distance. Here we can find distance by this kinematic equation when they mention uniform acceleration and initial velocity and time also. Here when they give distance, uniform acceleration and initial velocity, we can find time also. Okay. Fourth equation. Here fourth equation is ascent is equals to u plus a by 2 into n minus 1. Here ascent means that equation for particular nth second. This is the time calculating for particular nth second. We can know the distance ut plus half at square. Okay, this is for nth second. Okay, this is we can normally use, and this is for nth second. Okay, so these are the kinematic equations. So there are two mainly conditions. Body should go in a straight line and have uniform acceleration. These are very two important points. If they did not mention uniform acceleration, we should not apply these kinematic equations. Okay, and if body should not go in straight line and curvy paths, we cannot measure the distance, final velocity, acceleration like that by kinematic equations. Okay, so these are the kinematic equations. మీకు నచ్చితే లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ చేయండి.